Hi, in this video we are going to talk about one of the most fundamental data structures in any programming languages. This is the so-called array. Python doesn't have a native array data structure, but it has the list, which is much more general and can be used as multi-dimensional array as well. So what's very important that Python doesn't have an array data structure, but it has the so-called list. A list in Python is just an ordered collection of items which can be of any type. So let's see a concrete example. For example, I would like to create a one-dimensional array. We can do it with the help of lists. 1, 2, 3, 4, 5. In this case, we are going to store 5 elements or 5 items in the one-dimensional array. It's very important then, as for any other programming languages, indices starts from 0. So this is the 0 index, this is the index 1, index 2, index 3 and index 4. So if we would like to get, for example, the first item, we just have to get something like this, numbers 0 index. I would like to print it out, so print the first item in the numbers array or list is going to be the 1. Let's save it. Let's type python array.py, and as you can see we get the first item in the array, which is the number 1. I'm going to say that it is the 10, 20, 30, 40, 50, not to be confused with the values and the array indices. So the first item is going to be the 10, as you can see. The second item is the index 1, is going to be the 20. Okay, and there's the 20, as you can see. It's very important that this is what's called a random indexing. And because of this random indexing, arrays are quite efficient. So we are able to get items if we know the indices. Okay, it's very important that we can get in constant time complexity the given item if we know the index of that given item. We would like to get the 5th item in the array because the indices starts at 0, that's why we have to type 4, and this is how we get the 50 in order 1 constant time complexity. If we would like to iterate through this list, I'm going to comment it out. Okay, we are able to assign new values. For example, I would like to assign to be for example, the second item is going to be updated to 200. So if we print out the numbers where the index is equal to 1, then we should get the 200 because we have updated the second item, so where the index is equal to 1. Let's see it. Okay, as you can see, it is the 200. It's very important that arrays in Python are quite general. So we are able to insert, for example, names. I would like to insert the Adam. Let's see whether it's working fine. As you can see, it's working fine. So let's iterate through the whole array and print out the values. I would like to have a for loop, for example, for number. So for example, num in the numbers list, I would like to print out, for example, the given number. So this is how we iterate through all the numbers. This num is going to store the actual value and we would like to print it out. So if I run it, as you can see, 10, 20, 30, 40, 50. So this is how we iterate through a given one-dimensional array. Okay, and let's suppose the fact that we update the second item, so it's going to store a string as well. As you can see, it is quite generic. In Java or C++, we are not able to store, for example, integers, doubles and strings at the same time. We have to define that what's going to be stored, whether there's gonna be doubles, they are going to be strings or whatsoever. Python is quite convenient because we can mix the data types, whether they are integers, doubles. For example, we are able to print 40.5 and it's going to work fine. let's run our application again. As you can see, we have integers, strings, doubles, and so on. And okay, this is how we do it usually, but we are able to do it in a different manner. I'm going to comment it out. And we are able to use indices. So for example, for I in the range, the length of the array, so length of the numbers array, semicolon, we just have to get and print out the numbers array with the index I. It's going to be equivalent of this for loop. To be honest, I prefer this for loop because we are going to consider every single item which is going to be the variable num in the numbers, and we're just going to print it. But we are able to get the index, so for I in the range length of the numbers, and we just want to get the numbers I. It's going to be the same. So, as you can see, it's going to be the same. Let's suppose the fact that we would like to print out, for example, just the first two items. We are able to do it quite conveniently. We just have to print out the numbers, and we can specify that the starting index is 0 and the end index is 2. Okay, so if we run this application, it's going to print out 10 and Adam. So this is how we can use this semicolon operator to specify that the start index is the 0, so the first item, and we would like to get all the items up to the second index, 0, 1, 2. This is the second index. As you can see, it is exclusive in the sense that we are not going to get the third item, just the first one and the second one. What if we use just the semicolon? It's going to print out all the items. As you can see, 10, Adam, 30, 40.5, 50. We don't want to get the last item, then we have to use something like this, -1. It's going to print out every single item except for the last one. If we don't want to get the last two items, we just have to print -2. Then it's going to print out all the items except for the last two. So the 40.5 and the 50 are the two last items, and we don't want to print them out. It can prove to be very important, by the way, these operators. They are quite convenient. Or what if, for example, we would like to find the maximum? Okay, I'm going to comment it out. I will have the 300, so we just have to iterate through the given array. So for num in numbers, I'm going to store a reference to the maximum. Let's suppose the fact that the maximum is the first item, and we just have to check whether the num is greater than the maximum. Of course, we have to check it with an if. So if the num is greater than the maximum, then basically the maximum is going to be updated with the num. And then at the end, we just want to print out the maximum. Okay, so let's see whether it's working fine. I'm just going to print out the maximum, which is 300. And this is what we have been discussing. This is the so-called linear search. We have a one-dimensional array. We are able to access the items with the help of the indices. If we would like to get the first item, or sorry for that, the second item, because the indices starts at 0, we are able to get it in constant time complexity. But if we are looking for an item and we don't know that, okay, what's the index of that given item, then we have to iterate through and consider all the items in that given array. So what's going to be the complexity of this linear search? It's going to have the ordo n search running time or time complexity or whatsoever. But basically this is why complex data structures have came to be, because searching in an array is not going to be very fast. It's going to have ordo n running time if we don't know the indices. You may pose the question that, okay, why did we discuss that it has an ordo 1 time complexity for getting the items? Because in this case, we know the index. We know that, for example, we would like to get the item with the index 2. But if we are looking for the maximum, of course, we don't know the index by default, so that's why we have to consider every single item. So we have to sequentially scan this one-dimensional array, and that's why the complexity is going to be linear. This is why more complex data structures have come to be, such as, for example, binary search trees. Binary search trees is going to have the search complexity logarithmic n. Or that's why associative arrays such as dictionaries have came to be, because the search complexity is going to be ordo 1, constant time complexity, very fast. But the array is the standard, basic, most important data structure in any programming languages, so this is why we have to talk about it at the beginning. So basically what's very important, that if we know the index of a given item, then we are able to find it quite fast. Anyways, we have to look for that given item, and that's why it's going to have linear time complexity. Thanks for watching.